Hello everyone, today I will show you what is Mealy machine and what is More machine and how to convert a Mealy machine to a More machine and a More machine to a Mealy machine. So firstly the introduction. What is finite automata? Finite automata may have output corresponding to each transaction. There are two types of finite machines that generates output. The first is Mealy machine and the second is More machine. Now we will see Mealy machine. What is Mealy machine? A Mealy machine is a finite state automata which whose output depends on the present state as well as the present input. It can be described by 6 tuple q, sigma, o, delta, x, q0, where q is finite state and sigma is the finite state of symbol called the input alphabets. O is the finite set of symbols called the output alphabet, and delta is the input transition function where delta is equals to q into sigma, that gives us q into x, is the output transition function where x is q tends to o. Q naught is the initial state from where an input is processed. So here we will understand by the example. So firstly here we can see A. The arrow going inside the A means this state is the starting state, which is denoted by q0. Now we will see there are the two output from this A. Firstly this 0, firstly we give the input 0, then we reach from A to B. When we give the input 1 to A, then we reach from A to C. Similarly we can say from every state we can go to the other state on giving the input 0 or 1. Here q is equals to a, b, c and d, or we can say the set of a, b, c, d, and sigma is 0 and 1, and delta is the transition function which we will see in the coming slides. Now we will see the More machine. More machine is the finite state automata where output depends on only the present state. A More machine can be described by the 6 tuple, same like we have described the Mealy machine: q, sigma, o, delta, x and q0, where q is the finite set of a state, where sigma is the finite set of symbol called the input alphabet, and o is the finite set of symbols called the output alphabets, and delta is the input transition function. Delta is equals to q into sigma times to q into x is the output transition function, and here the same q naught is the initial state from where an input is processed. Now we will see an example of a More machine. This is the state diagram of More machine, and we can clearly see the first stage is the initial state or the starting state, and on giving the input 0 on the initial state we goes to another state, and same when we give the input 1 to the initial state, then we give go to another state. Now we will see the difference between the Mealy machine and the More machine. So first difference is output depend both upon present state and present input. We can clearly see from this. The present state is D and the present input is 0, and we get the x3 as the output for this 0 input, and same for the all state we get the output, which is not described here. Sorry. Now we will see another example of the Mealy machine, which will give us a better understanding. So here we can say the SI state when we give the input 0, then we get the output 0, and we move from the S1 state to S0 state. And same like here, when we are at SI state, when we give the input as 1, then we move to S1 and giving the output 0. And now we will see the Moore machine. Output depends only upon the present state, means that when we are at state A, then we will get a output lambda, and on giving the input 0, we will move from the state A to state B, and then we will get the output x1. And when we give the input A 1 on A, we will move to C and giving the output x2. Now the second difference is generally it has the fewer state than the Moore machine. Generally it has more state than the Mealy. Now we will see the conversion of the Moore machine to Mealy machine algorithm. First, the input is the Moore machine, and the output we get a Mealy machine. Step 1, take a blank Mealy machine transaction table format. Step 2, copy all the Moore machine transaction state into this table. Step 3, check the present state and their corresponding output in the Moore machine state table. If the state QY output is M, copy it into the output column of the Mealy machine state table wherever QY appears in the. Do not worry, we will get a better look in the example. Here, let's consider the following Moore machine. The step 1 was take a blank Mealy machine transaction table. Okay, this is the question. We will understand this table firstly. On this is the present state, this is the next state, and this is the output. On giving the input A equals to 0 and on giving the input A equals to 1. So firstly the state is A, that is the starting of the initial state. On giving the input 0 on A, we will move to D at giving the output 1. Same like on giving the input 1 on the state A, we will move to state B on giving the output 1. The same for full table. Now the step 1 and the step 2. Now we will apply the algorithm to convert the Mealy machine to Moore machine. So firstly, as in the step, it was written that take the blank Mealy machine transaction table format. So this is the transaction table of the Mealy machine. Now we have the written as same. Copy all the Moore machine transaction state into the table format. So from here we have copied all the next states to our Mealy machine table. Now we will see the step number 3. Check the present state and their corresponding output in the Moore machine state table. If the state QI output is M, copy into the output column of the Mealy machine state table wherever QI appears in the next. Here is the step 3. So here we have done a simple thing. You can see from these tables. A when we give the input 0. On A when we give the input 0, it's give the output 1 and moves to the state D. Same here, when we give input 0 to the state A, it moves to the state D on giving us the output 1. Same continues for all. Like this, when we give the input 1 on the state A, it moves from A to B on giving the output 1. So same here, A on giving the input 1 moves to B on giving. Once again we will see, on giving the input 1 on to A, we will move to state B on giving the output 0, and we see that the output of the B is 0. That this output which we are getting here, it we can clearly see from here, A output is 1, B output is 0, C output is 0, D output is 1. Simply we have written here the same, A output, D output 1, A on B output 0, D1, D1, A1, A1, D1. So we can see the similarity, C0, B0, and here also the C is 0 and the B is 0. We have just copied that. Now we will understand how to convert a Mealy machine to a Moore machine. Algorithm: input Mealy machine, output Moore machine. Step 1. Calculate the number of different outputs for each state Qi that are available in the state table of a Mealy machine. Step 2. If all the output of Qi are same, copy the state Qi. If it has n distinct output, break Qi into an state as Qin, where n is equals to 0, 1, 2 and so on. Q3. Step 3. If the output of the initial state is 1, insert a new initial state at the beginning which gives us the output. Firstly, we will check here the output related to the states. Firstly, we will check for A. A gives the output 1 here and also 1 here. Okay, so we'll do nothing with it. Now we will see the B. B is giving output 0 here and B is giving output 1 here. So we have to break it in the two states. Same for C. C gives the output 1 here and the output 0 here. So we also have to break C. And D is giving the output 0 and D is giving the output 0 here. So we have nothing to do with this. So we have seen that A will remain same, B will divided in the state 0 and B0 and B1, and C will also divide in the state C0 and the C1, and D will be. Now we will see the answer for this. So as I have said, the B is divided into the two states B0 and B1. Same, C0 is divided into C0 and C1, and A and D remains the same. Now we have seen that on giving the input 0, A goes to D, and on giving the input 1, A goes to B1. Same we have written here, and output related to A is 1. So we have written A1 and A1, A1 and A1. So we have written here the output 1. Same for B0, B0 or simply. So for B0, we can see on giving the input 0 on B, we will go to the state A, and on giving the input 1 on state B, we will go on the state D. So here we return both the same, but on giving the B0 state, we will get the output 0. and on the state B1 we will get the output 1. Now C0 and the C1. On the state C, when we give the input 0, then we move to C and giving the output 1, and when we give the input 1 on the state C, then we move to the state C0. So we have written the same here, C1 and C0, C1 and C0, and the output related to the C0 is 0 and the output related to C1. Now we will see what going on with the D. On giving the input 0 to the D, we will get the output 0 and we will move from D to B, or simply say we can say we will move to B0, and on giving the input 1 on the state D, we will move to state A getting the output 1. Same we have written here, B0 and A on, and the output related to D we can see from here, D0 and D0. So we have written here the D output is 0. Thanks for watching my video.